Let me recall something about pre-calculus. This is a radical expression. We can convert to trigonometric expression. It's an essential part of the trigonometric substitution. Entonces, the confusing part es que you assume que x is equal b over a sine theta. Under this supposition, sine theta. This is a square root b squared minus a squared, and this is square this que es b squared over a squared sine theta, sine square theta. So big a squared cancel, and b squared is a common factor, factor out b squared is 1b outside the radical, and inside the radical we have 1 minus sine square theta, que is cosine, and then it's b cosine theta. Now always we are doing this triangle to make it sketch. This is classical, this is theta angle. Entonces sine theta is equal xa over b, no? So isolate sine theta, entonces ax is the opposite, hypotenuse is b, right? And the adjacent is sine is the square root b squared minus a squared x squared. So square this minus this by Pythagoras theorem. It's exactly the same of the expression we have at the beginning. The problem is that when you have this triangle, we can find any trigonometric function. Okay, cosine, tangent, secant, and even using theta. Because sometimes we need to use theta. Okay, this is the first case, typical format. Okay, in this case, it's different because we have no radical and we have plus. So when you identification this kind of expression, the trigonometric substitution is x equal b over a tangent theta. Okay, let me substitution. This is b squared plus a squared. Replace x for this is b squared over a squared tangent squared theta. A squared is cancelled. B is a common factor. B squared 1 plus tangent squared theta is secant squared. Secant squared. You compare this and this. Let's see how we are doing the integration after. No? But this is the basic idea. And number 3 case is when you have a radical, but the order is different. It's a squared minus x squared minus b squared. So the x is positive. In the first case, the x is negative. And the substitution is x equal b over a again, but secant theta. Entonces es la que b square root is b squared over a squared secant squared theta minus b squared. Sorry, we have a squared here. This is cancelled. B is common factor. I factor out after the radical square root. Secant squared theta minus 1 que es tangent. Entonces x no. The expression is b tangent theta. Okay, let's see now application. Let's see application, and I forgot the triangle in each case. Look, the triangle in each case is always theta. It's always theta. Why is important the triangle? Because sometimes when you are doing the integration, we get a new trigonometric function. So we can represent this new trigonometric function using the triangle. So this is theta, and x is, okay, tangent theta is xa over b, no? By definition, tangent is opposite divided by adjacent, and this is then b squared plus a squared x squared. Of course, square root, no? Square root. It's very similar to the expression that we have. Here, different. Here is secant. This is x over b. Is secant. Theta. Pues cosecant. Cosecant, no cosine. Sorry. Es el recibo es b over x. Entonces, cosine by definition is adjacent over hypotenuse, and this is square root a square x square minus b square. It's exactly the same this expression. Okay. Let's see example now. Okay, let me try at least one elementary example. This is similar to the case 1, in which you define x like, well, b and a is 1, so this is sine theta, and the differential, that you design cosine theta d theta. Therefore, we have substitution, square root 1 minus sine square theta times cosine theta d theta. This is cosine. Cosine is cosine square. And you apply double angle formula. Double angle formula is, 1 plus cosine 2 theta. Double angle formula, no, half angle formula, sorry. Divided by 2 d theta. Okay, the antiderivative of this is theta over 2. Minus es cosine, es plus. Es plus, entonces the antiderivative de cosine is sine, divided by 2, entonces we have 2, entonces 4, 1 over 4, sine 2 theta, plus a constant. Now, you can leave it like that, no? No, because we have to express everything using the original variable, que es x. Okay, entonces I can discover here, double angle. This is 2i sine theta, cosine theta. Okay, and at least this is cancelled with this, is 2, this is theta over 2 plus 1/2 sine theta, cosine theta, plus 0. Okay, to finish this part, we have to construct a triangle. This is always theta. And I come back at the beginning. This is the beginning. This is sine. Sine is division, opposite side, divided by hypotenuse is 1. In this case, this is x over 1 is invisible. And the adjacent is square root 1 minus x squared. It's exactly the same this expression. Entonces, okay. In our expression we have theta over 2. Who is theta? Well, theta is, according to this expression, is sine inverse of x. And now multiplication sine and cosine. Sine is x, and cosine is adjacent over hypotenuse. So the final answer is sine inverse of x divided by 2, don't forget this 2, plus divided by 2 again, x, que es sine, and cosine is square root 1 minus x squared, plus 0. Final answer. Let's see another more complicated next time.